Assalamualaikum, can you hear me?
Welcome, all. I'm here.
Okay, all right. So yesterday we started a little bit of Lashatelier's principle, right?
Yes.
And we learned about what the equilibrium state of a particular reaction is. So we learned that the equilibrium state occurs in a both-sided reaction, and the equilibrium state is a dynamic state. In this state, the reaction does not stop. All right. And there are three principles for the Lashatelier's principle, and we learned the first one, that is for the effect of heat. Okay. And what did we say? Say for instance, if we see this reaction, the forward reaction is exothermic reaction, and the backward reaction is endothermic reaction. Now, whenever we are adding heat in the equilibrium state of this particular reaction, what will happen is it will do the opposite of opposite reaction than what we have done. Okay, so we have added heat. The reaction will go on that side where heat is being absorbed. Okay, so tell me, in which side the heat is being absorbed? This one is the endothermic reaction. This one is the exothermic reaction. Tell me.
The endothermic.
Right, endothermic one, right, where heat will be absorbed. Okay, and let's see in detail what they have said. The forward part of this reaction is exothermic when reactants nitrogen and hydrogen react to produce ammonia. They also evolve heat. Conversely, in the backward part, when NH3 converts to N2 and H2, it absorbs it. Therefore, heat is required to be applied. Okay. Now, we shall see according to Le Chatelier's principle what will happen as we apply heat on this reversible reaction. Okay, the reversible reaction means both-sided reaction. So, like, it will go both sides. According to the principle, if heat is applied, the effect due to that heat has to be neutralized. Okay, so this is a very important like word which I did not remember. The effect due to heat will be neutralized. How will it be neutralized? Say, for instance, if I apply 5 Newton force to the right, how will it be neutralized? It will be by 5 Newton. I mean, force has to be applied in the left side as well. Okay, that is how it will be neutralized. All right. So
Yes.
this is how we can like understand this thing. Application of heat. I mean, again, if I explain this thing, so uh, I'm adding heat. That means if we go in the direction where or the reaction where heat is being absorbed, the both of the effects will be neutralized. Okay. Application of heat will increase the forward reaction, increasing production of heat and will not neutralize the heat. Sorry again, application of heat will increase the forward reaction, increase production of heat and will not neutralize it. If the reverse reaction is increased, that will absorb more heat and neutralize the excess. Okay, all right. See, whenever we're applying heat, it will in like if in case you are like increasing the forward reaction, if that is the case, then that will not neutralize the heat. Okay, that means we are adding heat and then more heat is being added, which is not logical. Okay, it does not work. Okay, so if you are adding heat, that heat has to be absorbed. Okay, more heat can't be released. Okay, so if you are adding, say for instance, 10 kilojoule of heat, that 10 kilojoule has to be absorbed in the system. Okay, that is how it will get neutralized. If more 10 kilojoule heat is being produced, that is not neutralizing. Understanding my point? Like, forget about the
Yes.
terms mentioned here. Okay. And increasing production of heat, and that will not neutralize it. If the reverse reaction is increased, that will absorb more heat and neutralize excess heat. Okay. All right. So therefore, according to Le Chatelier's principle, we can say that if heat is increased, the reverse reaction will also increase. Okay. So this is the like basic point that we discussed before. In other words, the effect of application of heat in exothermic reaction will drive the equilibrium state to the left side. Okay, this is another important point. driving the equilibrium state to the left side. What does it mean? So obviously we learned that equilibrium state is a dynamic state. So what that means is that it has particular directions, like it could go to the left or it could go to the right. Okay. Consider it like a car moving on x-axis, right? It could go forward or it might go back. Same is the case here. Okay. So what it means by equilibrium state to the left side, it means that backward reaction will increase. Backward reaction will increase. Meaning ammonia converts into nitrogen and hydrogen. In the same way, we can say decrease of temperature in equilibrium will increase the exothermic forward reaction and neutralize the effect of lesser heat. So very easy. So see, the forward part here is endothermic, right? Because if you take this 180 kilojoule to the right side, it will be minus 180 kilojoule. That means that heat is being absorbed. Okay, understanding my point?
Yes.
Okay. Another thing, let me mention you. That is, whenever you are working with exothermic or endothermic reaction, it could be something like A plus B. I mean, these are like, say, for instance, reactants, and they are producing some products, and then delta H, somewhat like delta H. Okay. Now, if delta H is negative, the reaction will be in exothermic. Sorry, exothermic. All right. Okay. So delta H, if delta H is negative, then it is an exothermic reaction. If delta H is positive, then it is an endothermic reaction. Now tell me, in the forward reaction, what is the value for delta H?
In forward,
In this side, what is the value for delta H?
180
I mean, 180
kilojoules.
is, no, it's for the other one. See, delta H. What is the delta H here? If you see minus X kilojoule, that is given, right? That is given. All right. So, which means that the forward reaction will be exothermic. Okay. Now you might as well ask, but then how do I understand what will be the backward reaction? The answer to this is, for that you don't even have to now check the delta H, because if the forward reaction is exothermic, automatically the backward reaction will be endothermic. Okay, understanding
Yes.
your point? And
Yes.
here, tell me, in this particular reaction, what will be the delta H? There's a difference between like writing in this way and writing with delta H. Tell me.
What is delta H?
Okay. Delta H. Okay, have you forgotten? All right. Let me tell you. All right. So plus 180 kilojoule. Okay, that means that heat is being absorbed. 180 kilojoule heat is being absorbed in the system. All right. Now, what does it mean? That means is that there is like extra 180 kilojoule heat among the reactants. Okay. Extra 180 kilojoule heat among the reactants, which will be exerted. Which will be exerted. Okay. So now what delta H implies is that delta H will equal to say what can I say? Say okay, so delta H here would be, just 1 second. Let me actually, I sometimes get confused with this thing. So let me check, it will be better for both of us. Hmm, what's in the eighth chapter? Yes, okay, all right. See, in exothermic reactions, the total internal energy of reactants, in this case, what was it? N2 plus H2, was it? N2 plus H2, or say 3H2. Then what it creates is 2NH3. and the delta H here would be equal to minus 180 kilojoule. Sorry, it was not N2 plus 3H2. Okay, say for instance, I'm working with that one. So it was like minus 92 kilojoule. Okay. Now, what does that mean? Forget about if the reaction is correct or not. Okay, you will be given all the information. So in exothermic reaction, the total internal energy of reactants is greater than the total internal energy of the products. So what that means is N2 plus 3H2. Okay, so it has like a summation of internal energy, right? A total internal energy. Okay, and also this 2NH3 has an internal energy, right? Understand my
Yes.
point? Now, whenever, say for instance, they have a total internal energy, like the reactants have a total internal energy of, say, for instance, 80 kilojoules. Okay, 80 kilojoules. And the products have a total internal energy of, say, for instance, let's say 60, 60 kilojoules. Okay, 60 kilojoules. Now, where will the 20 kilojoule go? The 80 kilojoule has turned into 60 kilojoule. Where will the 20 kilojoule go? It cannot vanish according to the principle of conservation of energy, right? So where will the 20 kilojoule go?
In excess.
Okay, it will be excess and it will be like exerted
Like
into
plus.
the system. Okay, so plus 20 kilojoule to the right side. Okay, in the right side. Okay,
Yeah.
all right. And if you write it in a delta H manner, it will be minus 20 kilojoule. Now, what is the definition of delta H? That will make things clear for you. So, the delta H definition is that the total energy of the products minus the total energy of the total internal energy of the reactants. Okay, write it down. Delta H equals to total internal energy of products. I was about to say that, but I mean sometimes I like honestly I get confused between these two. That is why I checked it up. The total energy of products minus total internal energy of the reactants. Okay. Now, do you understand why delta H is negative for exothermic reactions? Because in exothermic reaction, heat will be in excess. Okay. So that means that the product's heat will be like, sorry, product's internal energy will be less than reactant's internal energy and the excess heat will be exerted. Okay. So that is how you can get the delta H.
Hmm.
Okay, good. So make sure you understand these two concepts because not always will you have like it will be written like plus 10 kilojoule or minus 50 kilojoule, something like that. Okay, all right. And if even if the like heats are given in say plus or minus format, what will you do? So for better understanding, okay, what you will do is take that plus or minus whatever kilojoule is there to the right side. Okay, it will make your understanding very easy. Okay, so what will you do? Say for instance, you are given with A plus B, then C plus D, then say A plus B at say here at minus 20 kilojoule. Okay, now you might find some confusion while understanding is this reaction exothermic or endothermic? Okay, you might make a mistake here. Okay, but whenever you will convert it to delta H, the chances are like very less. Okay. In that case, you will just have to remember that, okay, if delta H is negative, then it will be exothermic reaction. And if delta H is positive, then it will be a endothermic reaction. So what will you do? You will just say, for instance, okay, let me write down. So, so this reaction is given. Okay. And your question setter has told you to uh, I mean, explain if this reaction is exothermic or endothermic. So what will you do? I mean, you can do in either way if you write down the correct answer, but this is my suggestion to you. So I have added 20 to both the sides. Is there any problem? Just the basic equations rule, right? Is there any problem? Tell me.
No.
Okay, so 20 kilojoule. All right. So now, if it is in the right side, what you will do is, if you have to convert it to the delta H, just change the sign of the heat on the right side to convert it to delta H. Okay, what did I say? Say in the heat being absorbed or being in excess is like written as plus or minus in the right side. Okay, so what you will do, is just convert it to delta H by oppositing the sign. That will be minus 20 kilojoule. Okay, so now you can easily understand that it is a um, exothermic reaction. Okay, and also you could understand in this way that, okay, in the forward reaction there is heat in excess. What did I say? In the forward reaction there is heat in excess, or plus 20 kilojoule is extra there. So that means that it will be a exothermic reaction. Okay, so whichever way you feel comfortable, like understanding, it's okay. But I would suggest that a converting into delta H will be the best for you. So is exothermic, endothermic reaction and delta H clear now? I remembered that we have read this already, right? I think so.
I think so.
All right. Okay, so is everything clear? Tell me. The conception of this thing
Yes.
has to be clear, okay? All right. So now
Yes.
so we are here. Now tell me, what do you think should be the effect of adding or releasing heat? Or say, for instance, yes, not releasing heat. What I mean is, say you add heat and you take heat out of the system. What will happen? Say, first of all, tell me, what will happen in case of adding heat in the equilibrium state for this reaction?
Um, the left side will not have.
Follow my steps, okay? Write down the reaction and follow my steps for better understanding, okay? In whichever way you feel comfortable. But I would suggest that you take the heat to the right side, okay? Otherwise, you might get confused, okay? And convert it to delta H, okay? Convert it to delta H, it will make your like understanding a lot easier. Okay? This was my favorite question to answer because I was certain that if I just mention two or three conditions for like Lasatel's principle, then I will get full marks.
Wait, so delta H is equal to total internal energy products. That would
So delta
be
H equals to
total internal energy of products, which would be 180 kilojoules,
uh,
minus.
you don't have the internal energy of the reactants, neither do you have the internal energy of the products. You won't be able to find it like that. What did I say? You will say, if you turn it to this side, okay, you will get minus 180 kilojoule, right? Basic equations, right? Basic principles of
Yes.
equations. Now, what is the
Yes.
implications to that? It means that after like producing the product, 180 kilojoule will be absorbed in the system. Okay, 180 kilojoule will be absorbed in the system. If it was with the addition sign, then it would have been released But in this case, heat will be absorbed in the system. All right. And if you want to represent it with delta H, then you would have to just change the sign. That is 180 kilojoule. Okay. Either way you think, say in the forward reaction, I am thinking that, okay, 180 kilojoule will be absorbed in the system. Okay. That means it is a endothermic reaction. The forward reaction is endothermic reaction. Again, if you think with the value of delta H, then also you will understand the forward reaction is endothermic reaction. Because in case of delta H being positive, it will be an endothermic reaction. Okay, is it clear?
A bit, yeah.
All right. So what will you do? Just take the whatever heat is given to the right side, then see the sign. If it is minus, that means heat is being absorbed in the system. If it is plus, then heat is being exerted to the system. Then or you might convert it to delta H, whichever way you feel convenient. Okay, I used to prefer the delta H one. Okay, because it is easier for me to remember, because I always remembered that if delta H is negative, then it is exothermic reaction. It is easier to remember. Okay, otherwise you might have to, like, okay, conceptually think for a certain period of time. Okay, if it is plus, is heat being exerted or is heat being absorbed? So better remember it with delta H. Okay, so let me give another test then. So A plus B creates C, and plus 40 kilojoule. Okay. So now what will happen if I add heat in the equilibrium state of this reaction?
Yes.
Mhm.
Minus 40 kilojoules.
Uh, what is my minus 40 kilojoule? Delta H, right?
Delta H, yes.
Delta H. Okay. So what does that mean?
That is expelling. It is it is the opposite of absorbing.
I
It is
mean,
emitting.
emitting. What do you mean by emitting? Emitting is okay. So you are saying that it will emit energy. Is that what you're saying?
Yeah,
In which direction will it
yes.
emit energy? Okay,
To the right.
to the right. Okay, not to the right. Like, and don't say that.
Like in the direction, like
There is no like direction
forward
for
direction.
energy.
Forward.
So you would say it like, if the forward reaction occurs, then a certain amount of energy will be emitted or exerted. Okay. Okay. Now, I understand what you have said, but what it will mean is that energy will be released from left to right. Okay. So, whenever you will read vectors, you will read that energy doesn't have any direction even. Energy is a scalar component. Okay. It's not a vector. All right. So, direction for energy does not make any sense. All right. So, okay. All right. You are correct that in the forward reaction, energy will be emitted or exerted. Okay. So now if I add heat, what will happen? It has to neutralize the effects of adding the heat, right? How can it be
Yes.
neutralized? How can it be neutralized? The
Um,
effects of adding heat.
yeah.
Are you
Uh,
understanding the term neutralization? Okay,
no.
neutralization means, okay, so then you have to ask questions. Okay, say for instance, what is neutralization? See, say for instance, let me give you an example with say a football match, as football is going on right now. Say a team Australia has scored 3 goals. Okay, that means they are winning. Team Australia has scored 3 goals. That means they are winning. Okay, so Australia is 3-0 up with someone. Now, how can their opponent neutralize Australia's effect of winning? Tell me.
By losing. Oh, sorry, by
Yes,
winning.
by losing. No, I mean, yes,
Losing, sorry.
the opponent has to be losing and Australia has to be losing, right? For that, they have to concede 3 goals, right? Now, see, Australia were winning by scoring 3 goals, and they can neutralize their effect of winning by conceding 3 goals. So, again, if I come back to the reactions, if I am like adding heat, the effect of it will be neutralized by absorbing the heat. If I'm adding heat, if I write it down, if I add heat to the system, the effect of that will be neutralized only by absorbing the heat in the system. Absorbing the heat in the system. So if you add, you have to like absorb. Utilize only by absorbing, sorry, not absorbing, absorbing the heat in the system. Absorbing the heat in the system. Okay, if I rephrase it. So see, if you are adding something, its neutralizing factor is absorption. If you are winning by scoring goals, the neutralizing factor is conceding goals. Okay. If you are say spending money to buy the products, okay, the neutralizing factor will be to save the money. Okay, understanding, like it's like the opposite thing. If you don't even remember the term neutralizing, just remember that the opposite thing will happen. So now see, in case of the forward reaction, what is happening? In case of the forward reaction, heat is being exerted, right? Is that correct?
Yes.
Heat exerted or released or emitted, whatever you want to call it. And in the backward reaction, heat is being absorbed because obviously it is the endothermic reaction, the backward reaction. Understand?
Yes.
Okay. So now tell me, if you add heat in this scenario, what will happen?
Um, it will be neutralized by not
Yes.
absorbing
It will be neutralized by absorbing. Okay.
by absorbing.
Right? Because see,
Yes.
adding or exertion, these mean the same. Okay. Think about it. In the forward reaction, what is it happening? It is heat is being added to the system. If you even if I stress on the words add as well, okay, so you are adding heat, but in case of forward reaction, heat is being added to the system, right? Or it is being released to the system. So whenever I add heat, it cannot add more heat to the system. It has to be absorbed by the system. Okay, so in whichever direction it occurs, you will have to do or you will won't have to do that, like the reaction will itself do that. Okay, understanding my point?
Yes.
Okay. Okay, another practice, because I won't get to like the other two principles before clarifying this thing. Okay, let's see how
Okay.
much clear are you. Okay, so again, E plus F, so G minus, say, plus okay, minus 30 kilojoule. Okay, tell me, what is the effect of adding heat in the system? What is the effect of adding heat to the system in the equilibrium state?
It is absorbing 30 kilojoules of energy. And
Yes,
if you increase both the like thing by 30
not saying
kilojoules,
you if you add heat, okay? You have to
if you
specific
add
with the term. Okay,
if you
if I
add
add heat,
heat,
what will happen?
the It will be neutralized by absorbing the 30 kilojoules.
Yes. In that case, what will be the direction of the reaction?
It will go forward.
It will be a forward reaction. Okay. And don't say that it will absorb the 30 kilojoules because like you don't know how amount of heat am I adding. Okay. All right. I did not say that if you add 30 kilojoule heat. Okay. All right. Say this is the reaction that is occurring, and in the forward reaction, what is happening is 30 kilojoule heat is being absorbed by the system. Okay. So whenever you are adding heat, that means the neutralizing factor that is absorbing the heat has to occur. So in whichever direction it occurs, it will occur. Correct? So I
Yes.
don't know the amount. I cannot quantify it. Okay. So now, if I like reverse the question, so if I want to absorb some heat, say I have already said that if I add heat to the system, then it will go in some direction. So if I say that if I want to absorb heat from the system, what will happen then?
Um, yes.
Think about it. It's not
Um,
difficult. What is the opposite of absorbing? It is like adding heat, right? In which reactions heat is being added? In case of which reaction heat is added?
forward.
Uh, in case of forward reaction, heat is being added. Okay. It
Yes.
is minus 30 kilojoule, right? I explained that this minus 30 means the heat is being absorbed in the system. Okay. All right. Understanding your point. If you convert it to
Yes.
delta H, what will happen? If you convert it to delta H, it will turn like plus 30 kilojoules. And in case of which reaction is the delta H positive? Check again. Check your notebook. In case of which reaction is delta H positive?
Exo
Exothermic. Did
exothermic?
I write that?
Endothermic.
Endothermic, right? In case of
Yes.
endothermic reactions, delta H is positive. So that is why I'm always saying that convert it to delta H. Otherwise, you will make a mistake. Okay. All right. So the forward reaction is, tell me, endothermic or exothermic?
Endo.
Okay. That means the backward reaction will automatically be exothermic reaction, right? So now what did I
Yes.
say? You have to absorb, I want to absorb the heat. Okay. Say in the equilibrium state. So to neutralize its effect, what will happen? Tell me. And is the question clear? I want to absorb the heat in the equilibrium state. So what will happen for the reaction's direction?
Um, I don't get that answer. Question, sorry.
Okay, so if I rephrase the question, what I mean is that what was I saying up until now? That is, I add heat to the system, and you are answering. Okay, so based on that, so there should be a neutralizing factor in the reaction. So if in the left direction heat is being absorbed, that is neutralizing the effect of adding heat. Okay, or if getting to the right is absorbing the reaction, absorbing the heat, then it will go to the right. In whichever way, it has to perform the opposite to what I have done in the system. So if I have added heat in the system will absorb the heat. If I want to absorb the heat of the system will add or exert heat. Okay, I have made it very clear. I have given all the hints. Now tell me. I have already said that if I want to absorb heat from the system will add heat. Okay, now tell me in which direction will it go?
Uh, okay, I think I've been confused more.
Okay, okay, let me show it to you first then. Okay, we have time in this meeting. Okay, let me give another link. Yes.